Today we are going to see about Unit 4 Introduction. And Unit 4 we have two methods, two strategies. One is backtracking, another one is branch and bone. Before I go further with this introduction to backtracking, let me recollect and remind you what are the different strategies we have applied so far. So, firstly, we learned divide and conquer. What is divide and conquer method? There, in we took a big problem, then we divided the problem into a number of sub-problems, and each sub-problem is solved. And when we combine all those solutions, we get the solution to the given problem. So this divide and conquer is very effective, and we have seen what is merge sort using divide and conquer, binary search which uses divide and conquer, quick sort using divide and conquer, and of course matrix multiplication, Strasson's matrix multiplication. The second strategy that we have seen is greedy method. In the greedy method, at each step, we were taking a local decision and we were going for local optimal selection, hoping for global optimal solution. So, for example, if you are going for from a path A, from a station A to station D, and in between you have station B and you have station C, and to A to B, suppose you have two paths. Which you will choose? You will choose, suppose this is 5 and this is 7. You will choose 5 because you want to travel with less cost. Then from B to C, again you will have 2 or 3 or whatever it may be. Suppose this is 6 and this is 4. Because you have already chosen 5, you have to choose 6, and then you have to travel all to D by that method. So, greedy method will take local decision, but that doesn't guarantee the optimal path. So, for example, if you see, if you choose this method 5 plus 6, 11, maybe this is 3. So, 11, 3, the total cost is 14 by the path, this path. And if this path, maybe suppose it is 7 for 11 plus 2, 13 only. But according to greedy strategy, in the first step, you will choose the less cost one without thinking about the further paths and further options. You will not explore the other options. You will take a decision locally. So, greedy strategy does not guarantee optimal solution. Optimal solution. And in greedy method, we have seen what is shortest path method, Prim's algorithm, and thirdly, in the last unit, we have talked about dynamic programming. Dynamic programming is very similar to divide and conquer in a sense that it also divides the given problem into sub-problems, but dynamic programming divides the problem into overlapping subproblems, whereas in divide and conquer, those are non-overlapping subproblems. So here, these are overlapping subproblems. And dynamic programming, it stores the computational results, stores the computational results in a table so that we can, whenever we take a decision, we consider all the options and we go for optimal solution. And you know that dynamic programming is based on the optimality or principle of optimality. If all the sub solutions are optimal, then the global solution is also optimal. So here you're seeing, what is that, 01 knapsack, optimal binary search tree, then traveling salesperson, all pairs, shortest path. Now let me introduce to you strategy, strategy which we call as backtracking. Backtracking. This method essentially involves a brute force strategy. What is brute force strategy? A strategy where we'll be exploring all the possibilities. We'll be exploring all the possibilities. So backtracking, it explores, it incrementally develops the solution space, which we call state space tree. And then whenever there are conditions or bounds, it will backtrack and it will not further continue that path. It will come back and it will take another path. It is something like exploring a maze. Suppose you are exploring a maze, you go to a dead end, then what you will do? When you know that it is a dead end, you come back. Even in backtracking also, you explore all the methods and all the paths. Whenever you know that it is not a valid path or a dead end, you come back and take new path. This is backtracking. Let me give you a simple example. Suppose you have a three-chaired bench and you have a boy, let us call B1, and you have a girl G, and you have another boy 2. Now, how many ways I can arrange these? That is combination. So it goes into the factorials. So I can I can arrange them boy, girl, and boy 2, boy 1, boy 2, and girl, boy 2, boy 1, girl, boy 2, girl, boy 1, girl, boy 1, boy 2, girl, boy 2, boy 1. 3, because there are 3 elements, we can arrange them in 3 factorial. Because it is 3, we could write all the possible options. But if it is 4 factorial, then it comes 24, and if 5 factorial, it goes to 120, and then it goes exponential. So what we do is we explore the possibility of all the arrangements. Now let us say, if I draw a tree, here I am starting, and in the first place I will put y1, and once I put y1, in the second seed I may put y2, and in the third seed I may put boy, girl 1 or girl. Now coming back here, after starting with boy 1, I have an option that I can put a girl and I can put boy 2. This is one. Then another way, I will start with boy 2 in the first place. Then I can go to boy 1, that way I can make boy 1 to sit, then the girl. Then after boy 2, I can, instead of keeping boy 1 and girl, I can keep girl and boy 1. Then, sorry, the third option is we'll start with girl, and once we start with girl, the second place goes to boy 1 and third place goes to boy 2. And another option is to go to boy 2 and boy 1. This is the total state space tree which we have explored. Now suppose I put some condition saying that this is uh, there is a condition that girl should not be placed in between two boys. Either she should be at first or she should be at last. Suppose that is the condition. And okay. So this was our. So what we can do is, because now coming to the first option. So this is first. This is 1. This is 2. This is 3. This is 4. This is 5. This is 6. 6 paths are there. Now because coming to first path is valid because girl is at the end. Now coming to the second path, if you see girl is at in the between boys. So this is not a valid path. So what I do is I should not go further here. So I have to kill this node. And this I cannot go further. So this is killed. So path 2 is not valid. So I come back here and I search for other paths. So I will not come to 2. Then coming to 3, 2 boys and girls, this is valid. Now again in the 4, this is not valid. So because girl is in between. So I have to kill this node. I will backtrack. I will not follow this. I will go back here and I will explore. This is okay. This is okay. Now I have 4 solutions. Out of 6 solutions, this 2 is not valid. This is not valid path. This is also not valid path. So the paths I have are 1, 2, 1, 3, and 5 and 6. See, here I am not talking about which one is optimal, which one is better. I am exploring all the possibilities. I am giving all the valid solutions. Now let me give you one more example, which is called 4 queens problem. 4 queens problem. So I have a chess, a board like chess with 4 by 4 size. Then this is 1, 2, and 3, and this is 1, 2, 3, and 4. 4 by 4 matrix of board. So I have to place the queen. I have 4 queens. I have 4 queens, Q1, let us say Q2, Q3, and Q4. So in row 1, I'll be placing Q1, and here I'll place Q2, and here I'll place Q3, here I'll place Q4. Now, the conditions, the bounds are that no two queens should be placed in the same row. I should not place Q1, Q2, Q3, Q4 in a single row. They should not be placed in the same column, and they should not be placed diagonally, adjacently and diagonally. So now let us try to explore the space tree. I will start here. So I will put in the first column, first row, first column, I'll put the queen in the first place here. So when I put, the possibilities are, I can put the second queen in second place, and third queen in the third place, and fourth. But that is not a valid option. So once you put the second queen in the second place, they become diagonal to each other. So this I should not explore. So what I can do, I can place the second queen in the third place here. So let me write x3 is equal to x2 is equal to 3. Second queen in third place. Then what will happen? What about the third? Third, if I keep in first place, same column. If I keep in second place, diagonal. If I keep in third place, same column. If I keep in fourth place, diagonal. So this path is not a valid path. Then no option for me. So I will keep it in x1 in the second column. Now let us say here in this column. Here I'll start x1 is equal to 2 or q1 is equal to 2. Second column I started. So once I put second column, if I go to x2 as 1, it will become diagonal. So that I will not explore. What is that option? X2 is equal to 1. I am not exploring it. X2 is equal to 2. It is same column. I will not explore it. X2 is equal to 3 diagonal. I am not going to explore it. X2 is equal to 4. I think this is okay. So here I start. So once we do that, again x3 as option 1, and if you cannot keep in 2, you cannot keep here because it's diagonal. So the only option we have for x3 is 1. Once it is placed here, now x4 you cannot place in first, you cannot place in second because it is diagonal, and you cannot place in 4. The only option is x4 is 4. So the solution is, we express in a column. The first queen is placed in 2, the second queen is placed in 4 column, Third queen is placed in first column, and similarly you can find out that the mirror image is another solution that we have. Those are the two options we have. Similarly, we can solve 8 queens problem where we have 8 by 8 board and unqueens problem. So in backtracking, what we are doing is we are exploring all the possibilities, and whenever the path is not leading to a valid solution, we are backtracking. This is what backtracking method